Today we're going to spend a small amount of time, 5 minutes, to go over our data streaming pipeline system demonstration. What this system does in a nutshell is it simulates the use of an application which then creates event data, sends that event data to an API which then persists it to a event broker, Zookeeper being the load balancer, although that's no longer needed, Kafka being the event broker. Spark then harvests these raw event streams, performs a transformation internal to the Spark engine, persists it to Hadoop. Hive then we use to create relational or non-relational representations of that HDFS data. We then use Presto to consume these reports. This is a web platform agnostic solution in that we're using containers rather than the sort of packaged streaming solutions that different web providers attempt to market to us. The background is that this system utilizes infrastructure as code, Docker-based containerization, virtual networks, API endpoints, message brokers, transformation engines, persistent distributed redundant queryable data stores, HDFS, Hive SQL tables, synthetic parameterized event generation, event transformation, persisting event streams, schema organization, most importantly making it reproducible. There are certain limitations. This will not work on an ARM or M1, M2 box as the images are x86 architecture images. There are certain prerequisites required: Docker, Docker Compose, Python, Python 3 is Python, and here's a script to install those prerequisites. So if we want to run this project end-to-end in keeping with our theme of making it reproducible, we go ahead and run this command, which clones it, moves into our clone directory, and then runs it. Let's go ahead and do it. And while this is occurring, and it's spinning up the system, let's look and see what that run command does. The run command is generating the commands from templates. It's then doing a permission sweep, and then it's running the actual command end to end. The Python script for the templates is really to adjust, to make it distributable so that if I move from one directory to another, the mappings into our YML files are good and they're appropriate for the particular environment. Then we perform our work end-to-end and start up the streaming process, the simulation of the stream to simulate user activity on the site. We of course have a Jupyter notebook which is exposed to work as our reporting framework. We're going to go ahead and run all these cells. Once all these cells are run, we then have reports, and we have some insight into the raw performance of the system. If I were to run this, so you see we're at 4925. I run this again, we see we're now at 6. I run this again, and we see we're now at 7, and that indicates that the stream continues to work through the system. Then of course we have the ability to create some summary reports, so we can see the different events that are occurring. And then we have the ability to generate some more detailed visualizations of those different events within the stream. And as we run it, so for example, if we're at 35 right here, as the system moves forward, we're now at 60. So that's a brief demonstration of how the system works. In order to explore it, you can also, or we can also, look at the command prompt, and every so many iterations of the stream it will then spit out some summary data. And we may also explore the system through the batch files that are in there, or we can directly connect to an individual container within Docker Compose to explore it through the bash file, through the bash shell if we wish to. There's additional implementation details, which gives a lot of detail about how each component works. That's within these two files, which are included here. And there is a video demonstration of the system end-to-end, which is a little bit longer and a little bit dated because there's been some changes, but still useful. Hope you enjoyed this brief demonstration. Thank you for your time, and let me know if you have any comments or questions.